This is Andy Gould with SEL, and this video will explore the use of SEL-5032 Accelerator Architect Software to start a new project, add devices to a project, and create datasets. In our example, we'll be looking at a system containing an SEL-2440 DPAC, an SEL-751, and an SEL-421-7. But the process will be very similar for most other 6150 capable devices within Architect. At the very beginning, we'll start with a brand new project, Accelerator Architect, and add devices to the project from the IED palette. Here is the 2440, and I will drag that into the project. I'm presented with the option to pick which class file version, and you'll want to know which firmware version is on your device when making this selection, as those are commonly tied to firmware. I'll pick the latest and give my device a name, and hit OK. The next window gives me two selections to make. Will I be using mode behavior control for this device in the project? And what control model do I want to be using? These are topics that are best to review in the instruction manuals and application guides. But for now, we'll check the box for enabled mode behavior control, and we'll use direct with normal security for our control model. If you need to change any of these settings later, like class file version or mode behavior control or control model, there's an IED upgrade tool for that. A few things to keep in mind before we get started. There was mention of mode behavior control when adding devices, and you'll want to know whether or not mode behavior control will be used in the system you're implementing, or if test mode or simulation mode flags will be designed to be interpreted or used by other devices within your system. If that is the case, we'll want to make sure we're not only publishing statuses, but also the quality for each of those points as well. If you're not sure, adding quality bits to your datasets will be the recommended path. Also note that the .q quality bit mapping for the logical node data attributes is different than the concept of message quality that SEL devices implement, which is used by subscribers to detect the loss of publisher's data stream due to TTL expiry. We will look at mapping message quality in another video, where we turn these datasets into publications and subscriptions via GOOSE. We're going to start with SEL-2440 DPAC here, as it is the simplest device conceptually. And note that the ICD file I dragged into the project from the palette contains a handful of default datasets and reports and publications that use these datasets. These are created by the 2440 development team, and they may be included in the default file that you have in your project. But for the purposes of creating this video for datasets, we're going to delete these default publications, reports, and datasets and start from scratch. This would be the typical approach to ensure that the appropriate data was being provided according to the requirements of the protection and communication scheme. If you're creating datasets for GOOSE, your focus should be on the important statuses that other devices need to know about. And in some cases, that may even be some select analog quantities as needed. We'll want to keep the dataset small to conserve bandwidth on the system. Thus, we only want to include the statuses and quality bits. On the other hand, creating datasets for MMS is another matter entirely, as that is a station bus and SCADA mechanism. Creating a dataset for MMS would typically include all the data structures needed for supervisory and control, including timestamps. You'll want to pay attention to deadbands and reporting types as well. This video will focus on creating datasets for GOOSE between SEL devices. Quick note before we begin. I'm using Accelerator Architect version 3.1.0.76. You want to make sure you're using at least this version or later to follow along here. In my example, I'm looking to create a nice, simple, and lean dataset to share the first 8 input context statuses from the 2440 DPAC. This would allow IOs from some part of your system to be shared amongst all the other devices in the scheme. Your application may vary. This is simply used for demonstration purposes. Under the Datasets tab, I'll create a new dataset here and give it a name and description. This will be part of logical device CFG. And for a GOOSE publication dataset, I'll put GPD as the precursor, followed by the device, followed by its little description here. I'll say inputs. And as far as the description field here showing up in the software, I'll say first 8 inputs from 2440. Now, as far as we building the data set here, I'll be picking from items in the ID data items list. And you'll see the functional constraint menu lets me pick whether I'm looking at statuses, measurements, set points, controls, etc. here. I know these are going to be statuses for my 2440, and I can use the find menu here to look up the word bit reference I need for N101. And you'll note it shows up right here under N1 GGIO9. If you're ever looking for something and can't find it, note that if I'm looking for that and don't find it, I might be looking under the wrong functional constraint. But for statuses, N101, I can find that under this logical node, and I have the status as well as the quality that I can drag over here. And the rest of those inputs are going to be sequential from right here in this list. I can see 102 through 108 as I go through here. And one thing you can do, you can control click all of these and drag them all at once. Now I've got my data set built. I'm pretty happy with that. And you can see the qualified name, what it's valid for, the description, and the size, number of FCDAs, and the directory size via MMS. We're going to follow a very similar workflow with our 751 device for this project, adding it to the palette, choosing my class file version, giving it a name, enabling this, and once again going through and deleting the defaults that exist in here. While we're here, it's good to point out the reason why these things are named as they are. B for buffered report, U for unbuffered report. B for buffered report dataset, U for unbuffered report dataset. These are MMS dataset reports. We can go ahead and delete those now. And then the dataset is by default. We can go ahead and delete those. Here we are starting from scratch. For the dataset I want to create here, I want to be able to produce and publish some protection elements for my 751. The 50 and 51 elements, the breaker status, and the target LEDs. I'll call this GOOSE publication dataset 751 protection. I'll make a note here saying 50 and 51 elements, breaker status. And here, when I do my search, if I know my protection word bits I'm looking for, like 51P1, I can find 51P1T right here and bring that over into my data set. I'll go ahead and get 51P2T as well. I should go ahead and get my 50 elements. I'm going to look for my 52A status. Note that the status for the breaker is under the XCBR for breaker 1, and so this is the one I'm looking for here. For GOOSE, I don't need to bring in timestamp because the relays aren't going to use it anyway, and it'd be unnecessary for the bandwidth of the application here. And let's go ahead and look for trip LED, which should be the first of the targets I'm going to need for this. So I'll take that. And the rest of the target LEDs will be found right next to that here. 1, 2, 3, 4, 5, and 6. And just before, if I want to select those all at one time, I can do that. Now I've got my 5150 and breaker status and targets. I'm going to be happy with that there. Now let's just say, for an example, that I have a 421. I want to publish an analog from this to be subscribed by the other devices in my scheme. I'll pick my 421.7 and I'll give it a name. Note that some of these 400 series devices have another option to pick here, which is either the 4-port or the 5-port Ethernet card. You're going to choose based on the hardware of the model you have. I'll select this and direct normal security and hit OK. Once again, I'm going to go through here and delete the default publications, delete the default reports. For the datasets, I'm going to tend to want to leave the SV datasets alone, as those are usually much more useful by the default than the GOOSE and MMS datasets. I will leave those as they are. If I want to make a new dataset to share things like frequency or phase voltage, I can make a new dataset here on my 421. GOOSE publication dataset, 421 analogs, frequency and phase voltage. So if I want to find and look for analog quantities among my functional constraints, I want to go ahead and choose the MX measure ends. And under the metering section here, under the Hertz measurement, I can find either the instantaneous or the dead banded magnitude value. I'm going to choose the dead banded version for our purposes here. So I can choose that as well as the quality and drag those over here. Then I'll go look at my phase voltages. And for A, B, and C, I'll also choose the dead banded magnitude. It'll keep the data stream a little bit limited from instantaneous values. So I'll choose the dead banded value for my phase B, as well as the quality, and phase C, dead banded magnitude, and that. Now I've got my frequency and phase voltages here with the dead banded values from my 421. Once again, this is just a primer for how to navigate data sets in Accelerator Architect, how to add devices. Please continue with our other Accelerator Architect videos regarding GOOSE publication, GOOSE subscription, MMS reporting, and more. Thanks for watching this video. Please reach out to us with questions at 509-338-3838. Thanks.